In 25 it states a square of mass 80 kg, its mass is 80 kg, and accelerates down a slope at 2 meter per second square. Its acceleration is 2 meter per second square. So now you know the mass and acceleration. So by Newton's second law we can actually, this acceleration is actually a kind of resultant acceleration. F equals m times a. So mass is 80 kg and acceleration is 2, so we have 160 Newton force. And there is a weight, about weight, like weight equals m times g. So mass is, we know that mass is 80 kg and weight is the gravitational acceleration is 10, so it would become 800 newtons. So weight is 800 newtons and the resultant resultant force is 160 newtons. Okay, so there are no hints about the friction force, that's why there is no like kind of that kind of force is not considered. The gravitational field acceleration, gravitational field strength or gravitational acceleration is 10, which I have used here, which is 10. What is the weight? Weight is 800 Newton and the resultant force is 160 newtons. So weight is 800, weight is 800 here, weight is 800 here, and the resultant force is 160 newtons. So 160 Newton is here. So we are left with only this option. So the correct option is this one. Okay, a hard stone hits the ground and comes to rest almost immediately. As the stone hits the ground, what is the direction and size of force acting on the ground? Okay, let's assume that it's a ground surface. Okay, suppose this is it's a stone which is going to hit the ground. Okay, so when it will hit the ground, the force would be in this direction, which is actually the applied force, and weight as well. At the same time, it's an action force, and at the same time there would be a reaction force which would be in opposite direction like this. Okay, as the stone hits the ground, what is the direction and size of force acting on the ground? So when the stone hits the ground, like it means it is applying some force in downward direction. Its direction is downward, and the size of the force on the ground is actually its weight plus it already contains some like it is already in state of motion. So due to motion it will have some extra like you can say a kind of momentum. So change in momentum is rate of change of momentum is also a force, so there would be some force as well. So let's see. The downward, like the direction is, like the first thing is direction, related with direction. So first thing is related with direction and second thing is size. Okay, so downward is the direction is correct, so it means we are going to consider only these two options. So upward force is incorrect. So next thing is equal to weight of the stone or larger than weight of the stone. So it would be greater than the weight of the stone. So it is larger than the weight of the stone because it already have some momentum as well. So okay, a car of mass, next is a car of mass 1500 kg is towing a trailer of 1100 along a level road. Okay, suppose here is a car and here is a trailer which is okay, one second, let us suppose that it's a rope or anything with which it is towed. Okay, the car mass is 1500 kg. Okay, is and the mass of the trailer is 1100 kg along a level road. Okay, the acceleration of the car is 1.3 meter per second. Ignoring friction and air resistance, what is the driving force? What is the driving force on the car? There is no friction, there is nothing else. So right now when these two are connected, actually both the masses would be considered. Yes. So suppose the mass of the trailer is 1100 kg and the mass of the car is 1500 kg. Both are connected by this towing rope or whatever rod or something like that. So we know by Newton's second law, F equals m times A. So m is actually the sum of these two masses, which is 1100 plus 1500, because both are connected with each other through some rope or something like that, and there is an acceleration which is 1.30. So it would be 2600 times 1.3. So 2600 times it would be 3380. So it looks option D. So the correct option is option D. So this is the correct option. Okay, now actually we are going to consider both the masses as a single mass, because both are connected with this rod by this rod. So that's why we just we added their masses and it became 2600, and 2600 is then multiplied with 1.30 and it became like 3380. Okay. Okay, next is a coin falls through the air from rest. Rest means its velocity is 0. Okay, its velocity is 0. When velocity is 0, acceleration is also 0, and eventually reach a constant speed. Constant speed means terminal velocity. When object is actually through air, then and its velocity would become constant, it means it is moving like there is a terminal velocity. Two forces P and Q acting on the coin. Yes, we know that, like the weight of coin is actually acting in this direction. This is the weight of the coin, and air friction is actually acting in upward direction. So this is the uh, air friction which is acting in upward direction. Okay, this is friction force or air resistance. I would say air resistance. Okay, now when we are talking about the constant speed means acceleration is 0. Acceleration is 0. When acceleration is 0, Newton's second law states mass time acceleration, and it would become mass times 0. It means resultant force is also 0. So now let's move to the question and see what is actually the original question. What happened to the force P and the resultant force acting on the coin before it reaches constant speed? Like before constant speed, like when it would be constant, then P and Q would be equal. P and like the friction force and weight are equal. Before that, weight is greater than P force. P is a friction force. Okay, and with the passage of time, P increases to become equal to Q. So before reaching to the terminal velocity or constant velocity, P increases and the resultant force decreases to 0. Like originally it reached you can see at the end the resultant force is 0, but 0 means this is when it would be a constant speed. Before that it wouldn't be 0, it may be 1, 0.5, 0.3, 0.2, 0.1, then it would become 0. So actually we would say it starts decreasing. P increases and resultant force decreases to 0. So now we have a common position like this. Now P increases and increases till friction force would become equal to weight. Before both of them would be equal, P increases and resultant force decreases. Okay, okay, the diagram shows a motorcyclist leaning over in order to move around a corner. It means like the motorcyclist is planning to take a turn, means it is going to move around a circular track. So when there is a circular track, it means there is a centripetal force, and centripetal force is towards the center of the circle. Okay, which force causes to move around the corner? Okay, so now if we look at if we look at the different possibilities, we can see like the D represents that the weight of the person is going acting in downward direction. I don't know, it may be some type of force. Here is another force which is a normal force. So, and here is another force. I don't know what is the name of that particular force. So it might be the center of gravity, but type of force I don't know. It's a normal force, and this force is actually responsible for its centripetal force, and with the help of this force, which is A, the possibility is that the motorcycle will lean lean over, and it will tilt in this direction. Okay, next is an aeroplane is halfway along a runway before it takes off. The aeroplane show the direction of four forces acting on the aeroplane. This is the like you can see thrust from the jet engine, like the force provided by the engine is acting in this direction, and the weight of the aeroplane is acting in this direction, and lift acting on the wings to move it in is in this direction, force on the wheels from the ground. Okay, both are acting in this direction. Okay, next statement is the drag forces on the aeroplane are negligible. Drag force means like friction force of air and something like that. Those are negligible. Gravitational field strength or gravitational acceleration, which is G, it is 10. It is well understood. The acceleration of the aeroplane is 2 meter per second square. So A is given, so I'm gonna mark it. So this is our acceleration of the aeroplane. What is the largest force? Okay, the force on the wheel from the ground, this one, it is talking about this one. The lift acting on the wings, like this one. The thrust from the engine is this one, and the weight of the aeroplane. Okay, so we have four forces, and we are going to consider that which one is the largest one. So let's check which one is greater. So suppose the mass of the aeroplane is 1000, and the thrust of the engine is in forward direction. So we can find out the force, which is, suppose 1000 is the mass and 2 is the amount of acceleration, so it would become 2000 Newton, which is acting in forward direction. So let's calculate the weight of the aeroplane, which is, suppose mass is 1000 times its gravitational acceleration is 10, so it actually becomes 10,000 newtons. So I can easily say that when it is moving with an like when its velocity is such that its acceleration is only 2, then I can most probably say that at that time its weight would be larger than other forces. So weight of the aeroplane is comparatively larger than other forces. Okay, the next is the front wheels of the front wheels okay, the front wheels of a car is in turned in a clockwise direction by the engine as the car accelerates towards the right, as shown in diagram. There is a force of friction between the wheels and the road. What are the direction of friction force on the wheel of the car and road? Okay, so friction force is always opposite to the direction of motion. So the wheels are, you can see, the wheels are going towards the right clockwise, so it means, okay, okay, so actually if we see, the wheel is going like this, like the direction of the wheel is going like in clockwise direction. So when it will come in contact with this ground, it is, the wheel is actually going in leftward direction. So the direction of force, like the motion is in this direction. At the same time, a frictional force acts opposite to this direction, so friction force would be acting in this direction. So direction of frictional force on wheel would be towards the right. So we have towards the right, like we have only two option like this. So now let's consider, like the tires have some printing on it, like there are uh, designs on it that causes some friction. So when now this is the friction provided by the ground to wheel. So now the wheel is going in this direction, so it's like the tire is rotating in this direction, so it actually provides the friction to the ground in this direction. So there are two frictions: the friction of wheel, which is also acting in the direction of its rotation like this, and this green is actually the friction which is provided by the ground to wheel. So we have two frictions of wheel to the ground, that is leftward direction like this. So we are actually we have this option like this. Okay, okay, the diagram shows three forces acting on the block. Which additional force will produce a resultant force of 3 newtons? So which additional force will provide 3 newtons force? So let's consider the total force right now. Okay, so currently the 11 newton resultant force, currently 11 newton is acting along the positive x-axis direction, and 5 newton is acting along the negative x direction. So we have actually 6 newton which is acting along the positive x-axis direction. So let's consider that if we add a force of further 3 newton in this direction. Suppose, okay, this 3 newton would be something like this size. So 3 plus 3 plus 2, it would be 8 newtons. So then resultant force would be 8 newton along positive x-axis direction, and oh sorry, 11 would be along positive x-axis direction, and 8 newton would be along the negative x-axis direction. So we will have 3 newton as a resultant force. So it means we need to add 3 newton force to the leftward direction. So 3 newtons to the left, this one is correct. Oh okay, we have only one correct option, and these are incorrect options. Okay,